Hello guys, we want to solve problems on the electric field under superposition theorem. We talked about superposition theorem in the last class, and I want you to listen to understand it well by solving this problem on that we are seeing here. So I would like you to listen when we finish solving this problem. It will clear our doubt concerning superposition, and it will make it clearer than what we think. Now, the question says, in a rectangular coordinate system, two positive point charges of 10 raised to power minus 8 columns each are fixed at the corners or are fixed at the point, right? 0.1, 0 and x2, y2 equal to minus 0.1, 0, where all distances are in meter. Find the magnitude and direction of the electric intensity at the following point: A, at the origin; B, S3, Y3 equal to what? 0.2, 0. C, at the coordinate S4, Y4 equal to what? 0.10, 0.15. D, S5, Y5 equal to what? 0.1, 0.1. These are the four questions we want to solve quickly under this question. Now, first of all, let's start with what? The coordinate system. Now, this is X. This is X. And let's say this is Y. This minus Y. This plus Y minus X plus X. This is a coordinate system. This is origin. Now, the said one that the charge of 10 raised to power minus 8 each are fixed at the point S1, Y1, 0.1, 0. So that means this is 0, S is 0.1, Y is 0. So Y can only be 0 along the what? The X axis. Y what? X is 0.1. Let's put it here. 0.1. Y is 0 here. So that means from here to this place is 0.1 meter. So this point is what? 0.1, 0. That is our charge Q1. Let's call it Q1. Now, of what? What is the value? 10 raised to power minus 8 column. Okay. They said, well, another one is fixed at minus 1, S2y, Y2 equal to what? Minus 0.1, 0. So that is here. Also, the negative side, this is negative x. So negative x is minus 0.1. The y is 0. So here is what? If you want to plot the graph now, here you plot what? Minus 0.1, 0 here. X, y is 0 along the x-axis. Negative 0.1 means you have to go this way. So this one is what? 0.1 meter. And this is what? 10 raised to power minus 8 columns again. Plus. This is plus. They say positive. So let me. Now it's clear. Now, what did they say we should find? Where all distances are measured in meter. That's why I make it meter. It must be 0.1 meter. You cannot put minus 0.1 because its distance is not. It's just minus is just to show you the side after 0 towards the side of negative x-axis. That's where you are going to plot. Just like you are plotting. Plot this one here. Plot this one here. Exactly. Now, the question says, find the what? The magnitude and direction of the electric intensity at what? The point origin. Sorry for that. At the origin. Now, what we want to do, this is the origin. Now, at that origin, You want to calculate electric field at this point. What did I tell you in the last class? You place a point charge there. A point charge with what? A polarity of this that is small in what? In what size? That will not what? Disrupt the location and the distribution of other charges. This location will not be affected. The distribution of the other charge will not be affected. Now, why we are putting point charges here, which is positive charge, now is to calculate the electric field here so that we can know their direction. Because without direction, because for the electric field has a direction. Without putting this in here, you cannot know the direction which this 10 bar plus 10 bar minus 8 column will go. This one you cannot know the direction. So with this one now, you can know positive and positive with what? Will repair, like let's say this is Q1 and this Q2. So it will repair like this at the origin. That is E1. So that is where E1 will go. What about this one? On this charge on this one, on this at this point of origin, it will now repair like this. This one is what? E2. You see that? So the electric field of this one is this, and the electric field of this one is this. Why? Because they repair. These two repair, then this one will repair. But we are not concerned about what happened here. We are concerned about what happened here at the origin. So the net what? Electric field at the origin is equal to what? E1 minus E2. Now, E1 is equal to what? E2 in this case. Now, look at it. Why is E1 equal to E2? Because they have the same distances measured from the origin. So the distance of this charge from here is 0.1. The distance of this charge from here is 0.1. So automatically means that what? If you solve with using what? K, electric field, determine the charge of Q1 over what? R or X squared, S1 squared minus K Q2 over X2 squared. So this is S1, this S2. You will notice that there is a problem here in the sense that it will not give you value. It will give you 0. Now, why I say it will give you 0 is because they have the same X. This is 0.1, this is 0.1. So automatically means that they will be the same value and they have the same charge. So the net electric field at the origin will be what? 0. You can press your calculator. 9 times 10 to the power 9. Absolute of what? 10 to the power minus 8 divided by what? That is for Q1. The distance here is what? 0.1 all square minus 9 times 10 to the power 9, which is K naught. That is what? What is our Q2? The same 10 to the power minus 8 divided by what? 0.1 square. At the end of the day, you are going to end up having the same value and you end up pressing what? Giving you 0 result. So the net force at the origin is 0. Let's take note of that is 0. That one is settled already. So let's go to question B, number 2. If assuming that number 1 now they are not having the same distance from the origin, it will not give 0, and they don't have the same distance and the same charge. It will not be what? Different what? Network net electric field will not be 0 again. So let me clean this side. Now we have number 2 to solve using the same diagram. Now number 2 says find what? The what magnitude and direction. Now don't forget number A questions now is what? Net force is 0. The direction is what? Is not going, it does not, because it's not moving anywhere, it's stationary, it's at rest. So if all of them is what? The direction of X, that means net electric field that X is along the S axis is 0. Now normally If you use your direction, you are going to have zero direction, zero angle. The angle is what? Going to be zero because it's not going anywhere. You understand now? It's equilibrium along the what? S axis, or let's say infinity rather. Because if you use your theta equal to tan inverse of what? Sigma F EY over ES, sigma ES. S is zero along net force along the what? The S that direction is zero. If you put zero here, any number divided by zero is what? Infinity. Tan of infinity is what? It's like about 90 degrees. But you know, this one is in equilibrium, so we cannot really talk about the direction. Is that clear? We cannot talk about the direction. It's not moving. It's not something that moves that you can calculate direction. If I don't move, it's just like I'm stationary. No direction. Imagine me standing, just standing like this. No left, no right, no direction left. So it does not have a specific direction here because the system is in equilibrium here. It's not moving anywhere. So in that case, that one is settled. Number 2, 0.2 command. We want to find electric field at 0.2, 0. Now, let me clean this one. Okay, no need to clean it. Where is 0.2? Let's move 0.2, 0. Want to find electric field at that point. Now I will move it. 0.2 should be somewhere here. This 0.2, 0 is positive 0.2. So it will be somewhere here. The charge. We want to calculate the electric field at this point, the net electric field at this point. That's what we want to calculate. 0.2, 0. Now, how do we calculate net electric field at this point, 0.2, 0? You know, from here to here is 0.1. So from here to this place now is 0.2. So that is what they are saying. Now, we are not calculating electric field at this origin again. So we move our point charge away from here. That means the point charge we move away from that place will now be placed what? Here. Positive point charge. That means the test charge rather. So our test charge is now here. Look at it. It's now here. Now, how do we calculate net electric field of these two charges with respect to this one? Because that's what we want to do now. Now, first of all, this one we have 0.3, 0.1 plus 0.1 plus 0. No, from here to here is 0.1 because from here to here is 0.2. So from here to here now 0.3. That's what it means. Now from here to here will now be what? 0.2. 0.2. You know why? Because from here to this place now is 0.1. From here to here is what? 0.1. So if from here to here is 0.1, from here to here is 0.1, because the difference between 0.1 and 0.2, 0.1 is now what? From here to here is 0.2, which is the measurement, which is from here to this point. Now, what you now solve. Now, what is the effect of this particular charge on this? The effect, like charges repair, so it will go that way. Let's call it what? E1. Now, what is the effect of this one, this charge Q2 on this one? This positive, positive. It will also repair it that way. So E2. So we have E1 and E2 going that way. It will go that way. So in that case, the net force at what? At 0.2, 0 is equal to what? E1 plus E2. Because it's now going what? In the same direction. And when two vectors are moving in the same direction, you add them together. Because why is it even going that way? No, this is positive, positive. You will repair that way. Positive, positive. You will repair that way. So making two going in that forward direction. So in that case, that be what? K Q1 over R S1 square plus K Q2 over S2 square. Please we simply with this one now. 9 times 10 to the power 9 times what? 10 to the power minus 8 divided by what? 0.1 square plus what? 9 times 10 to the power 9 what? Q2 is what? 10 to the power minus 8 divided by what? 0.1 all square is equals to what? So what do we have there? To press your calculator. That means you are going to add these two together. Now, this one should be what? 10 to the power minus 2. If you come up, that means that is 0.9. It should be what? 0.9. But this is what? Minus 2 minus 10. 10 minus 9 and 9 times 10 to the power 9 times 10 to the power minus 10. You got 10 to the power minus 1. That is 0.9. 0.9. 0.9 plus 0.9 is what? That is 0.18 or 18 carry 1.8. Confirm it for me. These two are when you add it together. So for what I'm seeing is 1.8, but let's confirm it. Now there is something, the distance we are using the former distance. So where is x1? This is s1. Sorry. S1 is from here. Look at it, from here to this place to the charge. This is Q1. What is S1? 0.1 meter to this place. Because we have to measure the distance of the charge to the where we are calculating electric field from. So this charge is what having a distance of what from here is 0.1. Then that is this one is 0.1, correct? Then from here to this place to the what is 0.3. 0.3. I think that is what it's supposed to be. So work with that one for me, because from here to this place is 0.3 now. You understand? From here we need to 0.3. You know the Q2 have a distance of 0.3 from the place we are calculating it from then 0.2, then the Q1 has a distance of what? 0.1 where we are calculating from, because from here to here is 0.2, from here to here is 0.1, that means from here to here we have 0.1. So it will not be 1.8. So that's wrong. So let's see get the right answer, and so that we can move ahead. This is what? That is 0.9 plus this one is about 3 times 9 times 10 to the power minus 2. 9 times 10 to 9, that's why now will give us what? Minus 2, then is 0.1. What do you have? 10 is per what? 4. Newton what? Per column. Let me confirm it. Sorry. Permit me to confirm it, please. We have what? 9 times 10 to the power what? 9 times 10 to the power what? Minus 8. Divided by 0.1 square. That is 9,000. The first one is 9,000 plus 9,000. So we have 9 times 10 to the power what? 9 again. The times what? 10 to the power 8 minus 8. Then 0.3 all square. That's 1,000. So that is what? Plus 9,000. It was 10,000, which is, you are correct. 10 to the power what? 4 Newton per column. Excellent. So we have solved this one now as what? B is what? That is why I want my 4 10,000 meter per column. This meter per column, please. The unit is meter per column. It's electric field. So E is what? That. Now let's go to the next one. Next one.